So section 2.2, number 23, we're going to look at this problem and determine and algebraically show that this thing has zeros at x's that are given, both algebraically, and then there will be kind of a disjoint jump, and then I'm going to show you graphically using grapher. Okay. Now the equation is x cubed minus 6x squared plus 5x. Okay. Now the claim is that this function is 0 for the x values f of x equals 0 for x is equal to 0, 5, and 1. Okay? Alright, so to check this algebraically, what we do is we plug these x values into the function and we see whether or not the function actually equals 0. Okay? So let's check x equals 0. Alright, so it's going to be 0 cubed minus 6 times 0 squared plus 5 times 0. Okay? Well, 0 cubed is 0. That's nice. 0 squared is 0, so we're going to get 6 times 0. Well, and 0 is 0. Okay? Anything times 0 is 0. So this is 0 minus 0 plus 0. Well, adding and subtracting 0 doesn't give us anything. So we do get a 0. So this one, chink, checks out. All right. Now let's check the next one, x equals 5. Okay, so this one's, well, we're going to have to multiply 5 by itself a bunch of times, but that's okay. Okay, everywhere where there's an x, we plug in a 5. 5 cubed minus 6 times 5 squared plus 5 times 5. Okay, all right, 5 cubed. Well, 5 squared is 25. 25 times 5 is 125. Minus 6 times 5 squared. 5 squared is 25. 5 times 5 is 25. Okay. 125 minus 6 times 25. 6 times 25. 5 times 6 is 30. 6 times 2 is 12. Carry 12, add the 3 is, this is 150 plus the 25. Okay. Well, now we can gather up the positive pieces. 125 plus 25 is 150. 150 minus 150. Well, this is the same one thing subtracted by itself. So we get a 0. Okay? So that one, chink chink, also checks out. All right. Now let's check the last one, x equals 1. Okay? Now, if x equals 1, that means everywhere where there is an x, we'll replace that with 1. So we're going to get 1 cubed minus 6 times 1 plus 5 times 1. Okay? Well, 1 cubed, 1 times 1 is 1, times 1 is 1. 6 times 1 is 6. The minus carries on. 5 times 1 is 5, and the plus carries on. Okay? Again, adding the positives together, 5 plus 1 is 6. We only have one negative, the minus 6. Plus 6 minus 6 comes out to be 0. And that is the check algebraically. This function is 0 at all of these points. Okay? Now, let's take a look graphically. So continuing verifying our zeros, this time graphically. So our function is x cubed minus 6x squared plus 5x. Okay? Now, if we look at the graph, we look like we have this nice parabolic piece, but it kind of looks like it's coming back up. So this is not going to be the proper region to show what's going on. Okay? All right. So we don't really care much about anything less than 0, so let's get rid of some of that information. We want to capture some of the stuff that's happening beyond 5, so let's do that. Okay? in addition, let's make sure we stick with our major marks and get marks every half in the x direction. Okay. Now, if we want to figure out what's going on, where our zeros are, one thing we can do is we just click near the function. We can trace it along, and we see that this thing, right around 0, right, when x is 0, our y is roughly 0. Okay? If we continue our trace along, around 1, our y is also 0. So it looks like 0 is a 0 of this function. It crosses the x-axis there. X equals 1 is also a 0 of this function. This function is 0 at y as well. Y is at x equals 1 as well. Okay. Now, following along, on this end, well, stuff kind of happens pretty quickly. So what we can do is we can zoom in on this point. Let's go from, say, 4.5 to 5.5. That'll stretch out that part of the function. I forgot a minus sign, didn't I? Yep, I sure did. Okay. So if I trace now here, at 5, this thing is awfully close to 0. It's crossing the axis at 5. So that looks like our zeros at 0, 1, and 5 are nice and verified graphically there as well.